Okay, so this review is to help you prepare for the exam on moles, and I'm going to try to work through it with you and make it as clear as possible. The first question says, which representative particle would best be used to describe the following? So if I look at this, this is an ionic compound, and if it's an ionic compound, how do I know? Well, these are polyatomic ions, pluses and minuses. Then the best way to describe the representative particles for an ionic compound are formula units. This is simply an element off the periodic table, so it has atoms as its representative particles. And this is 2 nonmetals, so that is a molecular compound. So we call this representative particle a molecule. Okay, now you're going to need a periodic table to do this correctly, and you're going to round to the tenths. From the periodic table. Okay, so I want to know how many molecules of water are there in 36.7 grams of H2O. So I'm going to come down here and say, well, hydrogen, I have 2 atoms of hydrogen. Each of them has a mass of 1.0 grams. So there's 2 grams there. I have 1 atom of oxygen. And on the periodic table, it's 15.999, so I'm going to round up to 16. So water has a gram formula mass, or a molar mass, of 18.0 grams. So I'm going to set up a dimensional analysis. I'm going to write down what I was given first, 36.7 grams of H2O. And I know that 1 mole of H2O is 18.0 grams of H2O. And then I know that 1 mole of H2O has 6.02 times 10 to the 23rd molecules of H2O. Now I want everything to cancel out except for the word molecules, so these will cancel. And notice I'm just canceling the units. So the math involved would be 36.7 times 6.02 times 10 to the 23rd. Get that answer and divide by 18.0. When you do that, your answer, and you need to make sure you can do this on the calculator, your answer is going to come out to be 1.23 times 10 to the 24th molecules. I have 3 significant digits here, 1, 2, 3, so I need 3 in my answer. Okay, number 3 is next. It says convert 4.35 times 10 to the minus 3rd moles of K2S to formula units, because it's an ionic compound. We talk about formula units. So I'm going to take 4.35 times 10 to the minus 3rd moles of K2S. And I want to say that 1 mole of K2S is going to be 6.02 times 10 to the 23rd formula units of K2S. And I want you to put these units because as we get harder and harder in chemistry, these are going to be your friends. But right now I'm only dealing with K2S. I will get into situations where I have reactions and I have more than 1 compound involved, and you can keep it straight with your label. So might as well practice it now. So the math is going to be 4.35 times 10 to the minus 3rd multiplied by 6.02 times 10 to the 23rd. If I do that correctly, I should get 2.62 times 10 to the 21 formula units. Practice, make sure you get that on your calculator. Now I want to take my molecules of NH3, 2.63 times 10 to the 21 molecules of NH3, and I want to convert that to moles. Well, 1 mole of NH3 has Avogadro's number of molecules, 6.02 times 10 to the 23rd molecules of NH3. Cancel, cancel. I should have just moles left. I'm going to divide this number by this number. If I do that correctly, I should get 4.37 times 10 to the, ooh, that looks terrible, 4.37, pretty pitiful looking right there, 4.37 times 10 to the minus third moles of NH3. Number 5 says find the number of molecules of carbon dioxide and 4.56 moles of carbon dioxide. So I have 4.56 moles of CO2. CO2, that looks like a 2. And I want to convert that to molecules. Well, 1 mole of CO2 has 6.02 times 10 to the 23rd molecules of carbon dioxide, and it's molecules because it is a molecular compound. So I'm going to multiply this quantity by 4.56, and if I do that correctly, I should get 2.75 times 10 to the 24th molecules of CO2. Alright, number 6. Find the number of moles of lead and 647 grams of lead. So 647 grams of lead, 1 mole of lead, use my periodic table, has a mass of 207.2 grams of lead. Grams of lead will cancel. I'm going to divide 647 by 207.2, and if I do that correctly, I get 3.12 moles of lead. Okay, we move on down to number 7. Number 7 calculate the GFM of C15H34O4. That's the same thing as the molar mass. So you want the mass of 1 mole, so you go to the periodic table and you say, well, I have 15 carbons. Each of them has a mass of 12.0. I have 34 hydrogens. Each of them has a mass of 1.0 grams. And I have 4 oxygens. Each of them has a mass of 16.0 grams. So now I'm going to get that value. So 12 times 15, if I do this in my head, that's 180, I believe. Oops, and I need to keep that decimal place, my bad. 34 times 1.0 is 34.0. And then 4 times 16 is 64.0. So now I need to add 180 plus 34 plus 64. And those are all in grams. So that's 8 there. And 8 and 3 is 11. 11 and 6 is 17. So I got 278 grams per mole for my gram formula mass or my molar mass. Calculate the number of moles in 358 grams of sucrose. Well, before I can do that, I have to figure out how many grams are in 1 mole. So I'm going to say, well, I have 6 carbons. I have 12 hydrogens. And I have 6 oxygens. This gives me 72. This gives me 12. And this gives me 96. 96 and 12 is 108. 108 and 72, I hope it's 180. Okay, so now I know the molar mass. This is the molar mass. But that is not what the question asked me. It asked me for the number of moles. So I'll clean that up a little bit and figure it out. Okay, so I have 358 grams of sucrose. And from the work I just did a minute ago, 1 mole of sucrose is 180 grams. So if I divide 358 by 180, I'm going to get 1.99 moles. Okay, number 9. Number 9 says, oops, went too far. Number 9 asks you to calculate the mass of 6.42 times 10 to the 10 to the 5 molecules of C3H9O5. So I have 3 carbons, each of them are 12 grams. I have 9 hydrogens, each of them are 1 gram. And I have 5 oxygens, each of those are 16 grams. 16 times 5 is 80, 9 more is 89, 89 and 36 is 125. So that's my molar mass of C3H9O5. Now I need to convert that into, convert the molecule into mass. So now I'm going to set it up as 6.42 times 10 to the 5th molecule of C3H9O5. Alright, and then I know that 1 mole is 6.02 times 10 to the 23rd molecule. And then I know that 1 mole of C3H9O5 has a molar mass of 125 grams. So if I do all of that math, the mass will be to multiply this times that and divide by 6.02 times 10 to the 23rd. When I did that, I got 1.33 times 10 to the negative 16 grams. Okay? Alright, an 18-gram sample of water. Well, that's 1 mole. How do I know? Well, I did the molar mass, and it comes out to 18 grams, so I have 1 mole. I have 6.02 times 10 to the 23rd molecules of water. And then they want to know the total number of atoms. Well, there's 2 hydrogen atoms and 1 oxygen atom. So there are 3 atoms for every molecule. And I have that many molecules, so if I multiply this times 3, I'm going to get 1.81 times 10 to the 24th atoms.